Hey everyone, my name is Nicholas, and for quite some time I've been wanting to make a series where I talk about geology and paleontology and stuff, and so I thought the best way to get that started is to get everyone up to speed with a very abridged history of the world. Quick note though, I am going to be making a focus on the history of life as that is my main area of knowledge. Now, the Earth began roughly 4.5 billion years ago as a whole bunch of rocks and dust out in space. So gravity started drawing together these rocks and dust and formed a big molten ball of rocks. Now, this period of time we call the Hadean. This is the period of time where the Earth has not yet solidified. It's still mostly molten. Now, this was all kind of a boring time because, there's nothing here. The Earth is just molten. It's just kind of slowly cooling. Except for that one time, a big rock was late for the party, slammed into the Earth, and actually broke a chunk off, which ended up becoming the Moon. Now, after a while, the Earth, with its new satellite friend in tow, began to cool. Atmosphere began to develop. Oceans began to form. And this period of time we call the Archean. So there's oceans now, there's bits of land forming from volcanoes, and we start to see at the very end of it maybe some evidence of very early life. And that is what brings us into our next eon, the Proterozoic. This is where we start getting our first solid evidence of life. Now, at the beginning, it's just these little dudes, little single celled organisms. Now, most of them are getting along just fine in a mostly anoxic environment, till these dudes come around cyanobacteria. Now, what makes them interesting is they start photosynthesizing. They start taking that CO2 and creating oxygen. Now, the problem here is most things don't really care for oxygen much. I know, hard to think about given that pretty much everything on Earth seems to need it nowadays, but at the time, it was pretty lethal. Killed off most everything. Those things that survived ended up becoming the ancestral life forms for everything. Well, life began getting more and more complicated over time, becoming multicellular. And so at the end of the Archean, we start getting interesting little dudes. These weird little dudes containing very little hard tissue, mostly soft tissue, meaning they don't preserve particularly well, but interesting nonetheless. We call this the Ediacaran fauna. It's at the very end of the Proterozoic. Now, what happens next is a very important event in the history of life on Earth, the Cambrian explosion, or less dramatically called the Cambrian radiation. Now, this is such an important event that everything before this, which is most of the history of Earth, is referred to solely as Precambrian time. Now, the Cambrian radiation is a mass evolution event where just all of a sudden all sorts of different creatures started to evolve. We start to see creatures like trilobites, Anomalocaris, ammonites, this thing, that thing. Just all sorts of creatures start appearing. So at this point, the seas are really just teeming with life, although the land is pretty barren right now. Not much going on there. But that is soon to change. Now, as we head into Ordovician, we start seeing all sorts of new creatures develop. We start seeing corals, rugose and tabulate corals, not like modern scleractinian corals. Anyway, I'll talk about that in a different episode. But we also start seeing fish, not like modern fish, though, like weird, jawless fish. But more importantly, the land is starting to get colonized. We start seeing the first land plants, which, again, aren't like normal plants, they're like weird, mossy plants. And also like ancestral bugs as arthropods start to move onto land. And the next period after that is the Silurian. And in the Silurian, it's upgrade time. We go from having weird and jawless fish to having like less weird, jawed fish. We go from having primitive mossy plants to like modern ish vascular plants. And we even go from bugs being just odd little dudes to being like legit bugs. So once we go into the next period, the Devonian, big things start happening. We start seeing land vertebrates. The fish are learning to walk. So we see Tiktaalik here, the earliest known tetrapod, kind of the first amphibian, as it starts to come onto land and develop into better land creatures. We also see these massive armored fish called placoderms, like Dunkleosteus here. So stuff's getting real weird at this point. But not as weird as the next period. Because our next period is the Carboniferous, also known as that time the bugs got really big for some reason. Now, what's going on at this time? Stuff's warm. We start getting really cool plants. We start getting trees. These trees end up actually being like the trees that formed into our modern day coal deposits. Because at the time there was wood and microorganisms didn't currently know what to do with wood and couldn't really decompose it very well, so it got preserved and turned into coal. Cool stuff, but not quite as cool as the bugs. For whatever reason, the bugs got really, really huge during this time. For instance, we got Meganeura, the massive dragonfly with a 70 centimeter wingspan. That's about 27 inches for those of us who use real units. We also have Arthropleura, the freaking 8.5 foot long centipede. 2.6 meters for those of us who use fake units. Anyway, that was weird. Time to move on to the Permian. So, throughout geologic history, supercontinents have been breaking up and forming, breaking up and forming over and over again until we have everyone's favorite supercontinent, Pangaea, during the Permian. Now, what lives on Pangaea? Well, weird lizard tiger things. Everyone's favorite not dinosaur, the Dimetrodon. Other synapsids, which are the mammal-like reptiles that those two are. Arthropods. Other reptile-type creatures. Lots of stuff. Which, it doesn't end very well for them, because the Permian ends with the largest mass extinction ever. Some estimates place it at 90% of all life on Earth died during this mass extinction event. Now, with the entire Paleozoic out of the way, we can start moving on to the Mesozoic, starting with the Triassic. And yes, it is now dinosaur time. During this time period, we start seeing a lot of ancestral forms of the more well-known dinosaurs. We start seeing prosauropods, ancestors to the later sauropods. Not nearly as big and possibly capable of limited bipedal motion. We also get some ancestral theropods like Dilophosaurus, who Jurassic Park would have you believe was really little but was actually like 10 feet tall. So that's neat. Also, Pangaea has just started breaking up at this time, just a little bit, but it's going to be slowly breaking up throughout the entire Mesozoic and onward. And I would be remiss if I didn't tell you that dinosaurs were not actually the dominant form of life on the planet at this point. They were actually fairly few. And now we move on to the Jurassic, or that one time dinosaurs got really big for some reason. Now, the entire climate of the planet was warm and fairly wet at this time, which has a lot of plant life. And a lot of plant life means you have a lot of plant eaters, or some really big plant eaters. This is when the sauropods got really, really big and really widespread. Sauropods like our friend the Brachiosaurus here. Now, along with the sauropods came large predators, like the Allosaurus here and other fairly large theropod dinosaurs. We also got some of the more interesting ones, like Stegosaurus. And we move on to the Cretaceous, home of everyone's two favorite dinosaurs, the T-Rex and the Triceratops. Now, at this point in time, sauropods have largely gone away. They're not nearly as widespread as they once were. Also, flowering plants have made an appearance for the first time. Earth is starting to get really interesting. I mean, we all know how this ends, but it's getting really interesting at this point. Anyway, after our dino-killing meteor hits, some dinosaurs become more avian, turning into the more modern birds, and also one of the many survivors were small mammals. Now, these small mammals start to develop a lot over time, as does the climate. So, throughout the Cenozoic, the current era we're in, the temperature of the world kind of fluctuated wildly, going between like warm periods and ice ages. There were actually several ice ages. However, the big one everyone likes to talk about was toward the end, and that was the Pleistocene, also known as that time mammals got really big. During the Pleistocene, we start getting what we refer to as the Pleistocene megafauna. We start getting woolly mammoths, woolly rhinoceroses, giant ground sloths, saber-toothed cats, early dudes, and loads of other really big animals. Now, unfortunately for these really big fur-covered animals, the temperature did go up at the end of the Ice Age, so That's not great for them, and this rise in temperature likely was a massive part of the reason we don't have woolly mammoths today. So that gets us to pretty much where we are today, with the continents in their normal places, Earth's climate about where it is, and humanity about to screw everything up. So, yeah. So that should get you pretty much up to speed on Earth's history. Now, I will talk more in detail about various other things in future episodes of this. If you'd like to suggest a topic for me to talk about in a future episode, leave a comment. If you happen to like this stuff, like the video and possibly even consider subscribing. Anyway, see ya.